All right, let's dive in. Today, we're talking about a really cool shift in how we build AI applications. We're going to look at ditching those old, brittle, one-way pipelines and stepping into a world of dynamic, smart, collaborative AI teams. And the tool that makes this all possible, it's called LangGraph. So if you've ever built an AI app that has more than one step, you know this feeling, right? It's that feeling where you're just holding your breath, hoping every single piece works perfectly. Because you know deep down that if just one little thing goes wrong, the whole thing is going to come tumbling down.
You see, the classic way of doing things, especially with stuff like retrieval augmented generation or RAG, it's totally linear. A query comes in, it goes to a search step, then it goes to a generation step. It's a one-way street. And the problem with that is, well, it creates a domino effect.
And this right here is the real kicker. If you have a poorly phrased search query way back at the beginning, it basically poisons the well for everything that comes after. The final answer is doomed, no matter how powerful your language model is. There's no way to go back, no do-overs, no chance to self-correct. Every single domino has to fall perfectly.
So, we've established that this old model is fundamentally brittle. It's fragile. So now let's talk about how we can build something a whole lot stronger.
This is where LangGraph completely flips the script. Instead of that rigid, fragile line of dominoes, I want you to think about it more like a box of Legos. You can connect them any way you want. You can create loops, you can create branches, you can build much more flexible and, frankly, much more resilient structures.
And that flexible solution is LangGraph. It's really designed from the ground up to turn that fragile house of cards into a robust, intelligent, and much more capable system.
So what is it exactly? Well, at its core, it's a library that lets you define your entire workflow as a graph. You know, a collection of nodes and the edges that connect them. And it's this simple graph structure that unlocks its most powerful features, like creating cycles, making intelligent decisions, and, crucially, remembering what's already happened. And this graph structure gives LangGraph some serious superpowers. Cycles and loops, that lets your AI say, whoops, that search didn't work, let me try again. Conditional branching is like a fork in the road. It lets the AI choose the right tool for the job. State persistence gives the whole system a memory. And modularity means you can easily swap out components. You can even build in a pause for a human to jump in and give some feedback. Okay, so that's all great in theory. But let's see how these features actually help us build smarter workflows in the real world. And we'll start with one of the most common challenges, routing. So check this out. Look at these 3 requests. They all use the word summarize. But think about it. Each one needs a totally different action. The first one? The LLM probably just knows that off the top of its head. The second one needs to do a live web search. And the third one? That needs to access some private database. A simple linear pipeline would completely fail at this. LangGraph gives you 2 main ways to handle this kind of routing problem. First, there's agentic routing. This is all about flexibility. You basically give an agent a list of tools and say, hey, figure it out. It might use one, or it might decide it doesn't need any tool at all. Then you have function calling. This is much more predictable. You're basically forcing the LLM to choose one answer from a multiple choice list, which gives you a lot more control. Now, the secret sauce that holds all of this together is state management, and LangGraph handles this with a feature called checkpoints. The easiest way to think about this is like an automatic save file at every single step of the process. It remembers the exact state of your application at every node along the way, and this enables something that is, frankly, amazing: time travel debugging. So picture this. Your AI gives you a bad answer. With checkpoints, you can look at the entire history, trace it back to the exact node where things went sideways, rewind the state to just before that bad step, manually fix the issue, and then just hit play and let it continue from there. This saves developers a ridiculous amount of time. Okay, so this is where things get really, really exciting. Because beyond just improving a single workflow, LangGraph lets us build and orchestrate entire teams of collaborative AI agents. So the first attempts at making multiple agents work together, well, they kind of looked like this. A total chaotic mess, right? Like a big bowl of spaghetti. Every agent could talk to every other agent, which sounds good in theory, but in practice, it was an absolute management nightmare. And this chaotic approach, as you can imagine, created huge problems. The routing logic was impossibly complex. Trying to add a new specialist agent, oh, that was a nightmare, because you had to go back and update everyone else. And it almost always needed a human babysitter to constantly step in and direct the traffic. It just doesn't scale.
So, to solve all this chaos, a much more elegant and powerful design pattern has emerged, and it's one that LangGraph is perfectly built to implement. It's called the supervisor pattern.
Instead of that spaghetti mess, you create this beautiful, clean hub-and-spoke model. Right there in the center, you have a supervisor agent that acts kind of like a project manager or a team lead. And this supervisor is the only one who communicates with the specialized worker agents on the outside. So here's how it plays out. The supervisor gets the main goal. It then acts as a router, and it delegates the first task to the right specialist. Maybe it's a researcher agent. That worker agent does its job and reports its findings, but only back to the supervisor. The supervisor then looks at the results and decides the next step, maybe calling on a coder agent or a writer agent to draft a summary. And the benefits here are just massive. The whole system is way more simple and organized. It's highly scalable. If you want to add a new coder agent, you just have to teach the supervisor about this new skill. You don't have to rewire the whole team. And it dramatically reduces the need for a human to constantly intervene. This all leads to an absolutely incredible concept: composability. What this means is you can build an entire AI team with its supervisor and all its workers, and then you can wrap up that entire complex graph and treat it like a single, reusable node. You can then use that team node inside an even bigger workflow, which lets you create teams of teams. I mean, this just blows the doors wide open for building incredibly sophisticated autonomous systems. You could have a research team that feeds a writing team, which then hands its work off to a marketing team, all automatically. It really just leaves us with one big, exciting question to ponder. What team of AI specialists are you going to build first?